Well, hi everyone. This is Scott King over at Zimperium, and thanks for joining McKeel Kemperman and I for today's threat advisory on the BlackRock mobile malware. McKeel, how are you?
Doing all right. How about yourself?
I'm doing good, doing good. Really excited to talk about this campaign and look at some of our updated research. And it's really interesting how this malware campaign was put together. So essentially what we're going to describe to you guys is what the malware is doing, what it's targeting, who it's targeting. We recently found out through a new version, it's actually looking for 297 different security apps to suppress. So really interesting findings later on in the presentation. But, really on the middle here where you're looking at the targeted apps. So these are the category of apps inside Google Play. 17% of the targeted apps inside this campaign are social apps. Communication apps at 11. The majority, in which everybody is interested in, is the finance apps. And these are crypto, peer-to-peer payment, mobile banking, stock trading apps, things like that. But this campaign is actually targeting new apps. Because of the coronavirus epidemic, we're seeing a lot more entertainment, dating, video, and shopping apps that are actually trying to capture credit card information, not just banking credentials. McKeel, any things that you want to highlight before we get going?
The interesting thing is that we're seeing this sample kind of evolve, and we'll get to some of the details there, but the amount of apps that are being targeted is actually increasing over time, which is interesting and maybe somewhat troubling.
Yeah, because it's an ongoing campaign, right? So they take, software evolves and it's always updated. The malware campaigns are updated as well. And what they're really trying to do is they're looking for credentials and credit card information. So this is just a high level view of what we have seen at Zimperium from phishing threats, right? So these are phishing on mobile devices, either through email or SMS messages. And we've seen a huge increase since we've all stayed home and we're forced, into kind of a different lifestyle, right? We're staying home, we're social distancing, we're using mobile often, we're at home working with our own devices. So there's different security problems there as well. And we have school devices, right? McKeel, I've got older kids, so I've got 2 school devices. That comes with a handful of problems. So phishing is really the best way to get information because it's easy to trick people. And from a malware perspective, so this is just a timeline of about 7 months of data. This is only malware data that we've seen at Zimperium. And you'll notice that there are humps in this chart. So the humps represent specific malware campaigns. The left hump here, which is March, April, these are your coronavirus contact tracing apps that saw so much malware. Lots of apps in the news of being incorrectly developed. They have data leakage issues. And then in June in the summer, we saw this BlackRock campaign kind of come to fruition. And, we were detecting threats, McKeel, way before this thing was disclosed online. And we saw a lot of this banker malware. McKeel's on mute. I can see your mouth moving, McKeel, but you're on mute.
Sorry about that. Yeah. So we see a lot of these malwares out there, and they look similar to bankers. We classify them as malware, but until somebody snatches the sample, researches it, and gives it a cute name, we're not going to be able to kind of identify them specifically.
Yeah, I think that's part of the key is when these things come out, people say, hey, do you detect this? Do you detect that? So BlackRock comes out, do you detect BlackRock? Well, yes, we were detecting it before it had, a cute name because we do look at several versions of this banking malware. Of all the malware in the previous graph, you can see here that 16% of it is actually the banking malware, right? So this was where the BlackRock malware resided in. There are several samples that we detected, But 16% of all the malware is specifically trying to grab these credit card and banking credentials. So really, really dangerous, especially now since we buy everything on our mobile device. Like we don't go anywhere anymore, right?
Yeah, exactly. And if you're kind of, providing service to your end customers, through mobile apps that allow them to financially transact, potentially you're at risk here as well. The other point I'd like to make with regard to the classification of the malware to do is the BlackRock malware is effectively not very new. It is pretty much the fifth evolution of something that came to be in the world as Loki bot as a first, right? And it is interesting to see this progression of evolution. We'll dive into that in a little bit later. But it does need to get noted that we see a lot of the additional apps beyond the banking and finance getting sucked into the same type of attacks on malware.
Yeah, very, very important point that these things don't just pop up, right? They do evolve, and for good reason, because the average value for a fraudulent transaction for browser-based attacks, you can see here it's anywhere from $218 to $364 down in Australia, but on a mobile device, the average value is $764, and so that's nearly 3 times the average here, McKeel. Why do you think it pays to hack mobile devices?
Yeah, so obviously there's more money to be made. The transaction values are a lot higher. An additional interesting observation here is that we know from the data that 25% of fraudulent transactions on mobile originate with accounts that are trusted by the enterprise, but the transactions originate on unknown devices, new devices. So effectively, you'll have a user that's been a user of mobile or online services for about 90 days or more, and they all of a sudden go onto a new device, and that's where the fraud gets committed. So that is a significant chunk of impact to a business, and that would also warrant to looking fairly closely at what does mobile as a platform plays a role in these fraudulent transactions.
So that kind of goes in line, McKeel, with what we're talking about here. If 25% of the fraudulent transactions on mobile are trusted accounts with new devices, that would be very indicative of this BlackRock campaign, wouldn't it?
Yeah, that could very well be where a user gets the BlackRock on their device or on a new device, or their account is stolen and it's put on a device that has BlackRock or whatever it is. Right?
Yeah. Okay. So let's walk everyone through what this does. So this is how it works, right? So a user, and this, if you're developing a mobile app, this is your user. This is not you, but your user installs some type of utility app, right? So we've seen these things in updates. We've seen cryptocurrency converters containing this malware, but typically it's something that is very appealing and pretty targeted. So if I want to attack mobile banking apps and I'm providing a cryptocurrency converter, that's right in the sweet spot, right? And so then what happens is when the malware gets on the device, it basically updates itself and then it hides. So it'll take it, remove any icons. It's not in the app list. It's not, in the battery list. It's doing all types of things so the user can't see it and uninstall it. So what it needs to do is it needs to gain additional privileges on the device. So the malware will put a malicious Google update. It looks harmless, but what the user is actually doing is giving the malware all the permissions that the malware needs to go to work. So once you click OK on the malicious Google update, again, which would fool anybody, it compromises the entire device. So the device is now compromised, not exactly rooted, but just completely compromised. The malware can do anything. Then these are when you get to the fake overlays. So the overlay images are the exact copies of all of the banking apps, all the shopping apps. You type in your credentials and then you basically are surrendering your data to the attacker. So from a workflow perspective, the user, they can't tell the difference. But if you have underlying technology in the device, the behavior of the device acts way differently. But from a user perspective, McKeel, I haven't downloaded this malware. I don't have it on my device, so I believe I probably would be fooled too.
Yeah, there's a very high likelihood of that happening. And the way this really works is with a set of permissions regarding accessibility that you can see them commonly in apps for visually impaired people to magnify pieces of the screen or do other functionality to help people that are impaired to use a mobile phone. That's what these services are intended for. What the malware is actually doing is leveraging the same permissions along with some other device admin permissions to really control what's on top of the screen. And effectively, when an application is launched into that it's targeting, it will do an overlay specific to that particular application that is indistinguishable from the real thing. So we've looked at several samples that exert kind of this behavior. The last sample that we know about is from September 21st. It poses as a flash player, so when you see it on a device, it really looks like general flash player. It does need to be said that there's basically more out there which we haven't seen yet, or which we haven't identified yet, and it would be good to assume that will happen eventually, right? BlackRock is the 5th iteration in the Loki strain. There will probably be a 6th and a 7th, and there's good reasons to assume that it will happen because of the way that the BlackRock malware has been built. So what we've effectively seen is that instead of adding more functionality to the malware itself, right, the capabilities that it has, the adversaries have chosen to reduce it, right? They made it less obvious, that it has less capabilities. It's more focused on stealing credit card information and user data out of banking apps. You mind hitting the next slide? Yeah. So what we saw with this latest sample is that the backend that it's talking to has moved from the Ukraine to Russia, right? And we can see that in clear text inside the application, there is a list of apps I mentioned that kind of threefolds. The first list of applications are the ones that are being actively targeted with overlays to exfiltrate user data. So think about an overlay that is specific to that particular application to steal user credentials. The second set of applications, can you flip back one second because I wasn't really there. The second one is for credit card overlays, right? And this is more of the utility apps, the usability apps, the messaging, social. What's really interesting there, and we'll see another example of that, is that they've localized the way the overlay looks, right? So if you are in a certain geography, you will not get an ask for a certain credit card because it's not common there. Right? It's very targeted. The third set of apps is the apps that is trying to avert, right? So there's a lot of security apps out there, cleaner apps out there that could pose a threat to the malware. As soon as it detects these apps and you would launch it, it would automatically hide the app again. So you would never be able to see any detections in those applications from the malware. Yeah. You move to the next slide, please. As of yesterday, the backend of the command and control server was still live, so we could still approach it. We could pull data down. We were able to pull some of the overlays that are actually in there off the server. So that indicates that the sample that we have is still functional, and that also the adversaries are probably still benefiting from this at this point. Do you mind moving on?
Mikhail, did you try to log into this site?
I did not. No, I did not. No, that would be inappropriate. So when we look at how it communicates to the command and control server, is also very interesting. It uses an unencrypted channel, surprisingly. So you could really intercept the traffic. What you would see is encrypted payloads. Right? And potentially this is done to avert kind of detections when you're using known certificates that are blacklisted or whatever. The payloads are encrypted using a key, and funny enough, the key is actually visible in the malware. So if you were to be able to intercept that traffic and you have the key, you can actually see it sitting right there in the code. Can you move to the next slide, please? And it is provided with the exact encryption and decryption routines. So you really get handed all the information that you would need as a reverse or an analyst to understand what the payloads are and what they're sending, right? So a lot of this information is very openly available. Interestingly, what you could argue is that the attackers, kind of value sits for them in obtaining the information from the malware, but when they siphon it off the device, they're not doing a whole lot of work to protect it in transit effectively. Yeah.
Well, I mean, there's not a big deal, right? So they're already stealing information. So I guess they don't need to encrypt stolen information, right?
Yeah. So the final thing here that we're seeing is the actual code to retrieve overlay data from the remote server. So what you're looking at is the actual implementation of the malware figuring out which data to pull, literally a zip file with images and stuff, that is used to build the overlay to lay on top of an application. Right? And this is also a key indicator because for the next evolution, if you will, because this basically signals that they're already able to dynamically put content into the malware to adjust, if the app that they're overlaying on changes or if some other circumstance requires them to change those. The next thing would obviously be to have those static lists of applications that they now have embedded in their app on what they're targeting specifically to make that dynamic as well and getting obtained from a remote server, effectively making it unpredictable what is being targeted and making it harder for enterprise to protect themselves because they don't know if they're going to be targeted or not.
Interesting. So it's just like in-app advertising, right? So that all those functions exist. So this is an intelligent ad campaign for malware.
Yeah, yeah, and what we also saw is when they're communicating to their backend, they're retrieving or they're using the IMEI as kind of a consistent parameter across that communication, probably to identify specific devices. Because some of the capabilities that we've not delved into yet is the ability for the malware to actually receive a command from the server to go and do something, start an app, flush all the notifications on the device, maybe flood some SMSs or do any of that kind of more nefarious stuff. Yeah.
And when you were looking into this, Mikhail, were there certain functions for device manufacturers? If a device has some functionality that device B doesn't, are they looking to that level, or is it just kind of standard permissions?
So they do make a lot of provisions for different versions of Android, right? Because obviously the accessibility services that they leverage very heavily, how they're implemented and how they should be used vary across different versions of Android. So they've done a lot of provisions for that. I've not seen a lot of things for device specific. So there's one little example in here. For ACC devices, it deals different with power optimization or reboots. Yeah.
Okay.
Now, again, this is specific for indicative of a malware that's really wanting to target, right? Localizing the content to that the country associated with the device means that you can create a user experience that is so authentic that a user could never distinguish it from the real thing. Yeah. And like I said, we're seeing here that it's using one little phrase enabled in different languages, specific to that particular device country. But we also see, let's say, credit card data and other pieces of the app being specifically targeted on geos and adapted for those geos, which makes it for quite formidable marketing campaign with a nefarious purpose, effectively.
So this would, so earlier you mentioned the credit card overlay, right? So if you know location, were you indicating, for instance, a Diners Club card in the U.S., it may not be visible on an overlay in some other countries where Diners Club isn't available? Is that kind of the example?
That's exactly what they're doing. Yeah.
All right, that's pretty smart.
And then finally, right, so what the malware needs to do in order to be effective is stay active, and it's using a number of things to do so. Basically, when you reboot your phone, it automatically launches, right? It's trying to not be put to sleep by Android through a battery optimization, right? So there's a number of these mechanisms in play that they're using to stay alive effectively, right? Much like some of the security providers out there trying to do as well. And this really helps them to snatch those applications when they're running, right? And put the overlays on top of them. Additionally, it gives them more execution time on the device to receive commands and process them to do whatever the attacker wants them to do on the device.
That's pretty cool. I didn't realize that it was also excluding itself from the battery optimization. So that's that's a good way to remain hidden.
Yes. Yeah. So ultimately, right, when you're looking at defending your own app against things like this, right, and this is going to be one of many. Like I said earlier, this is the 5th iteration of the Loki malware. There's other variants and other malwares out there that specifically target applications for the information they have. If you want to defend against these, the first advice that I give is do not go and look for a solution that tries to identify overlays. Because simply identifying an overlay on your app is not going to help you. It will rather hinder your users when they're visually impaired or in need of something to magnify the screen, right? You'll need to have a mechanism in place that is effectively capable of identifying risk associated with a device. Obviously, malware is a very high level of risk, and then make your app aware of that. And that is exactly what our Xenon engine does. It's available as an SDK, can be embedded in an application within literally minutes. And from that point onward, you would at least get visibility on what kind of risks are posed to your app when it's running on users' devices. And what will happen is when our SDK runs inside an application is it will notify the host application that certain threads are being detected. So we're not just looking at malware. Obviously, that's an important thing, and we'll notify the host application of it. But also things like the integrity of the network, the integrity of the operating system, and a whole host of other things are being assessed for which threats can be generated. Once the threat is generated, the host application will know about this through a callback and can then effectively respond. And in the example that you're seeing here on the screen, the developers have chosen to provide notifications to the user, which obviously in a scenario where you're working with end customers, right, consumers, you might not want to do that, but at least your app is now aware of the security posture of the device it's running on and can take appropriate responses.
Okay, so this is optional, right, Mikhail? Like I don't have to tell my user what's going on, but the security team and the fraud teams can be aware.
Correct. So we see customers ranging from I'm not going to do anything on a detection and just send the threat information that is captured, all the forensics, to a fraud system and have the fraud system ingest that when it processes the transactions, just as indicators of fraud. We have also got customers on the other end of the spectrum that say, if I see X, Y, or Z, I'm just going to crash my app and not run on the device because it's not safe. Right? And all of this is specific to the use case of the app itself, right? The use case of the app will determine what response measures are appropriate.
Okay, it may depend on customer segment too, right? If you have a high net worth individuals that are used to transacting a lot of money, maybe the rules obviously are different than somebody else that maybe has a new account, right? Less than 90 days that we talked about earlier.
Yeah, we have banking customers that build trading apps who process literally millions and billions a day through these apps, and they will not take a single risk, right? So if they don't trust, they'll crash the app. There's just no way they will take a risk. We also have consumer banking customers that say, well, we spend the better part of 2, 3, 4 million with a marketing firm to design the best user experience. We're not going to impact that investment. We'll do the risk processing on the back end, right? What we always advise our customers to do is to take kind of a 4-step approach where we define 4 levels of risk, right? And then have 4 different levels of mitigations that you would tie into that. So If you have no risks on the device, it's going to operate as normal. Do you have a very high level of risk? You might want to log out a user, remove any local data, or even go as far as crashing the app. And where you put the stages in between is very much up to up to the customer itself and what's appropriate for the app.
Yeah, but I think you can't really do any of these remediation actions, right, Mikhail, if you don't have the data. So getting the data it's actually pretty simple, right? Just a simple app update, and you don't even have to configure remediation yet. Just read the data and really understand from a fraud perspective how what your exposure is to this malware, and frankly, Wi-Fi. As well, right? So everybody is starved for power and connectivity. So watch out for risky networks as well.
Yeah, we have a number of customers that go what we call the Christmas tree experience. They embed our SDK into their app. They update in, the public stores. It hits the devices, and basically all their customers light up like a Christmas tree. Because we find so many things in the wild where they would not have thought of beforehand, before they had the visibility, right? And with that visibility, we can then help them define a strategy to address the risk.
Yeah, well, if anyone has any questions, you can there's several options. You can contact Mikhail and I directly offline. You can ask a question now in the Q&A window, and we'll take questions, but some of the more common ones I've just listed here. And then if you want more information, we do have a blog available on the Zimperium blog. You can read basically what we walked through today. Send us an email at info@zimperium.com with your question, and we'll get to you as soon as we can. But first question, Mikhail, how do we install this into our mobile apps? We touched on it. Is there anything tricky about that?
No, effectively no. It's simply you drop the SDK into your application, and you have to copy paste a license key, make 1 or 2 method calls, and you're done. So this literally is a 10-minute exercise for general developers to get it up and running, to start getting the visibility.
And then we talked about BlackRock. That's an Android malware. Is this available on iOS?
Absolutely. So our SDK also runs on iOS as it would on Android. Obviously, the iOS is a different platform, different detections, and also different remediation capabilities that you ultimately be able to implement as a customer.
Okay. And then remediation steps. I know that you talked, Mikhail, about we advise people, customers, just to put the SDK in, start reading data. Mm-hmm. When do they start remediating threats? Like when do they start shoving customers into different journeys?
Yeah.
Is there a pattern there?
Yeah, definitely. What we generally see is that there's a high value transaction appetite to address first. So we'll dissect transaction data with the customer and the threat data that we find there, and advise them on how specifically to first address that segment of risk, because that's where the meat of the bone sits, right? So then after that, we'll go and dissect into less valuable but more bulk size transactions.
Okay. I did get a question. Can you show the infection process again? Probably not right now, but I'll send you, actually I have a video on my Twitter. If you want to go to Twitter and look for the Scott King, should be the first one available. So you can take a look there. And then again, if you want some more information, please, contact us. We're glad to help. Mikhail, thank you so much for joining me today. What do you have planned for fourth quarter? You looking into new malware, or what are we doing?
Yeah, so we just published a new blog on a new piece of malware. Obviously, we're going to closely watch this one, see some more evolutions, and perhaps our labs team can crank out a couple more CVEs.
Okay. Yeah, there's also there's a Joker malware on the blog too. So the last 3 articles are really, really good. So thank you so much, everyone, for joining us. If again, if you have a question, go ahead and send that in, and we'll take care of you today. So thank you so much for joining me, and appreciate the time that you invested.